section 4.1, Introduction to Area. In this section we're going to use sigma notation. This is sigma notation. The big E is the Greek letter sigma. In math it's called the summation symbol. The I could be any variable. A is the starting index, and that'll be a number. B is the ending index, and that'll be another number. And then the function, and the function should use the same variable as this variable. Example 1. Find the value of the sum of I plus 2 when I equals 1 to 5. Okay, so we're going to let I equal 1 first. Then we're adding because it's summation, so it's summing up. Then we let I equal 2, I equal 3, I equal 4, and I equal 5. And then you just total up everything and it equals 25. Or you could do this on your calculator. On the new operating system, you can use alpha window number 2 summation. That'll bring up a little template, and you just fill in the missing parts, hit enter, and it'll give you 25. On the older operating system, you have to go to second list math sum to pick up the word sum, then second list ops sequence to pick up sequence. Then you type in I plus 2, which is your function, the variable I, 1, which is your lower index, 5 is your upper index, and then 1 is an increment. Properties of linearity for summation. The first property says if C is a constant, then the sum of C times A sub I equals C times the sum of A sub I. The second property says the sum of A sub I plus B sub I equals the sum of A sub I plus the sum of B sub I. And the third property says the sum of A sub I minus B sub I equals the sum of A sub I minus the sum of B sub I. Okay, example 2. Suppose that the sum of A sub I when I equals 1 to 50 equals 65, and the sum of B sub I when I equals 1 to 50 equals 15. Calculate the sum of A sub I minus 3B sub I plus 2 when I equals 1 to 50. Okay, so first we're going to separate it out. So we take the first A sub I, and we can find that sum, and then we'll subtract 3 times the sum of B sub I plus 2. So they told us that A sub I's sum is 65. The sum of B sub I is 15, so 3 times 15 plus 2, and then just do the math, and it's 22. Example 3. Find the area of the shaded region. So this is the shaded region. This top of the shaded region is the curve y equals x squared plus 1. So the first thing we're going to do is we're going to inscribe rectangles so that the curve goes through the top left-hand vertex of each rectangle. So here's the first rectangle. The base is at 0.5, and it touches the curve at the left-hand corner. Okay, this is called the left-hand sum because it touches at the left-hand corner of each rectangle. Okay, now we're going to find the area of each rectangle. So this first rectangle, the width is 0.5 and the height is 1. The second rectangle, the width is 0.5 still, and this height is right here where x equals 0.5. So if you just plug 0.5 into the formula, it will give you the height of 1.25. The next rectangle is 0.5 times 2, and the last rectangle is 0.5 times 3.25. And just to make it easier to punch into your calculator, you can bring the 0.5 out and then just add up the y values, and that will equal 3.75 square. You can also use your calculator and it works the same way for both operating systems. So 0.5 is the width of each rectangle. Then you get the word sum, sequence. This is the function. X is the variable that we're using. 0 is the lower index because this first rectangle touches the curve at x equals 0. 1.5 is the upper index because this last rectangle touches the curve at x equals 1.5. And then 0.5 is just the width again of each one. Just punch that in and it'll give you 3.75 square units. This left-hand sum is actually an underestimation because we did the area of these rectangles, but all this yellow part was not counted in the area. Okay, so now we're going to circumscribe rectangles so that the curve goes through the top right-hand vertex of each rectangle. And this is called the right-hand sum because the curve goes through the right-hand vertex of each rectangle. Now we'll find the area of each rectangle. This first rectangle, it has width 0.5 and it touches the curve at x equals 0.5. So if you plug 0.5 into the formula, you get 1.25. For the second rectangle, it's 0.5 times 2. The third rectangle is 0.5 times 3.25. And the fourth rectangle touches right here at x equals 2. So you plug 2 into the formula and you get 5. So it's 0.5 times 5. Then just multiply 0.5 times each of the y values and you'll get 5.75 square units. You could also do this on your calculator. 0.5 once again is the width of each rectangle. Sum, sequence, the formula, the variable. Our first rectangle touched the curve at x equals 0.5. The last rectangle touched the curve at x equals 2, and then 0.5 is our width again. And that will give you 5.75 square units. This right-hand sum is an overestimation because we did the area of all the rectangles. So this yellow part is not actually part of the shaded area. And that concludes section 4.1, Introduction to Area.